Okay, so let's solve this next trigonometric equation. All right. So if we look at this equation, I only have a linear function, a linear term in my function, this cosine, right? There is no quadratic. There is nothing squared here. So I'm not going to use any Pythagorean identities, right? And in fact, in maths, right, we look to keep it simple as much as we can. We look to keep it simple. So we can come over here and we can say, okay, well, what would be the simplest method for solving? All right, so I've got the cosine of x minus 3 pi, all right, so 3 pi over 4, and that's going to be equal to negative 1 divided by root 2, right? If I subtract 1 and divide by root 2. All right, now I need to understand that negative 1 over root 2 is the same thing as negative root 2 over 2. All right, so what does that tell me? That tells me that, right, if I had the cosine of theta equal to negative root 2 over 2, right, if I had the cosine of theta equal to negative root 2 over 2, I would know that theta would have to be equal to, let's see, 3 pi over 4 or 5 pi over 4. Now, why is that? Well, let's consider where the cosine is negative, and that's in quadrant 2 and in quadrant 3. And let's consider our reference angle, and we know that that reference angle is pi over 4. So in the second quadrant, my angle would be 3 pi over 4, and in the third quadrant, 5 pi over 4. All right, but really this was just a substitution. My actual angle is x minus 3 pi over 4. So what does that mean for me? That means that x minus 3 pi over 4 must be equal to 3 pi over 4, or x minus 3 pi over 4 must be equal to 5 pi over 4. So that means that x must be equal to 6 pi over 4, which would be 3 pi over 2. And over here, x must be equal to, let's see here, 3 pi and 5 pi. That's going to be 8 pi over 4, which would be 2 pi. Now, if I look to the period of my function, right, all I have is a phase shift, right, no horizontal compression. So I know that the period of my function is 2 pi. So therefore, if I'm looking for all of my solutions, I'm going to have x equals 3 pi over 2 plus or minus 2 pi times k, or x equals 2 pi plus or minus 2 pi times k, which really could be then just said as 0 plus or minus 2 pi k, right? But we have to be sure that we specify where k is an integer, right? So you could use the notation, or you could simply say where k is an integer, right? So we know all our solutions are going to have this form, 3 pi over 2, and then multiples of my period, or at 2 pi and multiples of my period. Right? If I wanted to look at this graphically and verify my solution, come over to y equals, right? I've got the square root of 2 cosine function, x minus 3 pi over 4 plus 1, and I want to find when I'm equal to 0. Right, my window, right, from 0 to 2 pi, pi over 2 are each of my tick marks. I'll just look from negative 3 to 3 on the y-axis. And so here comes this cosine function that has had a phase shift. Right, and if I look at the cosine function that has had a phase shift here, right, let's just make sure. And we notice that the graph, I was missing a parenthesis, so we want to be careful. And the way I knew I was missing a parenthesis is I don't see that vertical move up by 1 unit. So I know I was missing a parenthesis, so I have to be careful there. So put it in the parentheses, plus 1, put in my graph, right? And now I can see I look a little bit better in terms of having a center line at 1. And I can see that, yes, in fact, at 3 pi over 2, and then at 2 pi, I do in fact have my intersections. If I wanted to look at more than one period, maybe I say from negative 3 pi to positive 3 pi, right? And look to graph, and I should be able to see that, yes, there is that repetitive pattern in terms of where those intersections are occurring, right? So where are all my intersections, right? All my intersections are at 3 pi over 2 or at 2 pi plus or minus a multiple of the period. Okay? So don't always think that you're going to have to make a substitution. Always look to keep it simple and say, hey, is this something that I should know? If not, could I do a Pythagorean substitution? And as you learn more, you have more options to go to. But always keep it simple to start. Say, hey, does the simplest solution work? And if not, what other substitutions might I try?